this. So we wanted this here, did we?
Yeah.
And what about the screen?
I think we just have to do without.
I'm just thinking, like, if I leave this over here, you can't see it, right? How about over there? Can you see it from there? Finish. You can go ahead. So, the first guy was able to actually use this particular dongle. I couldn't use it.
I do have a yeah, I do have. So, should I use one of that one or just use this one or this one? Oh, that's good. I have one. So was it hardware, is it?
Yes.
Awesome. Yeah, okay. Yeah, that's amazing. Yeah.
I'm going to copy it.
Okay, so then they share on the other.
Yeah, you see?
I don't know what email account what I'm just gonna
Hey, oh Gary, hey, how are you? I'm in a hurry.
看到那 copy，
对，我简单，是吧？前面给了先讲，所以你们就 surprise。
但是其实也就20分钟嘛。
对，是这样的，我就很难，
我看你 copy 又是前后端都 cover， 所以很难，这20分钟真的很难。
后端就一带而过，只是一个 story， 并没有什么特殊的。没关系，反正我估计那种。应该是3分，所以知道没有你。当然最好就是因为我是的话，
我们 team 非常 strict。
哦。
external speaking， 然后还没有拿到，所以我当时觉得
是吗？
Yeah, good. I didn't know.
没有人靠的最好。但他们会 screen。
That's why I would go online.
Yeah.
Oh, no, not saying just so you know that you're there's like
is there a camera or
exactly.
Yeah, that's the camera.
Wow.
I think
Okay.
I mean, I used to work in which is just word of mouth from here. It's just, yeah, teams and RPG. So, years ago, when I first worked here, it was here. So it was playing for clouds. And now it's completely
Hey all, just a 5-minute bell that will kick things off in about 5 minutes, so grab some food and drinks and stock up, and then we'll kick things off, get the night going. That's all good. All right, welcome everyone. If we can all get seated or standing, whatever you prefer, we'll kick things off. So while everyone's getting seated, who's not hiring these days? Cool, looks like everybody is, including us, but I'll have a note on that in a minute. I'm the CTO at Kogan.com, the host of React since, interestingly enough, I took a look back since 2015. Now, here we are thinking we're all cool using React and it's relatively new, but it's actually pretty old school. And it's probably time that, we're going to find a new framework. But, over that time, it's actually been pretty cool. 7 years, we've built up with 4,500 members. We've had COVID where we were on break for a while and everyone got to stream YouTube from around the world. We're back now with our locals and also streaming it. Hopefully online there is some viewers, but we're going to try and, in future keep the double streaming going on. And thank you for taking the time out of your days and nights to make it down here and participate. It's really good to see it back in action, and we're going to keep it going in person, as much as we can, as long as it's safe. So we've been sponsoring this event at Kogan for those 7 years, and just to give us a hiring pitch, we're a mid-size, I'd say, engineering team. We value community, developers, products and customers. We serve millions of customers, millions of products, and have, I was going to say millions of bugs, but we don't have millions of bugs, just probably hundreds. So we have hundreds of bugs, but like really big technical challenges that we need to solve at scale. And so progressing your craft, creating software and delivering value and getting shit done for our customers is something that interests you. You want to challenge the status quo, we're happy to chat. So yeah, apply. There's a dev blog, you can chat to anyone around here. You can probably also apply to all the organizations that are represented in the room because everyone's hiring. All right, so in terms of just some quick housekeeping, there's plenty of food and drinks, so please enjoy. Help yourself as you go. If you're helping yourself during the talk, try and do it like a bit quietly. The restrooms are through the door there. So as far as an airline person, you'll be like that. The emergency exit is to your left or right if you are facing my direction. I think there are some check-in codes in there, so use them if you haven't, in case there's like any issues. We can then contact people. It's not mandatory, but it's just there. We do finish at 9 o'clock sharp. So afterwards, if you want to continue on to drinks, there is the Palace Hotel just up the street, which has a good arrangement of alcoholic and non-alcoholic beverages. So on our menu today, we have got Gary, who's an engineer from Block. We've got Mayor, who was telling me about some pretty cool device he's building that detects, what is it? Rogue devices on Wi-Fi networks. So those of you carrying some, watch out, he's got it with him. And Harry, who is the development lead at Message Media. So let's invite Gary to the stage, and thank you.
Thank you.
I don't have a beer stand. It's not for you.
Okay.
Okay, hello everyone. I'm Gary Sung. Very excited to give a talk here. It's not only because our team was working on this since last year, and we are really happy to share of the learnings we have from micro frontend. Also because this meetup really helps me a lot when I was looking for my first full-time job 6 years ago. And I was just popping up into the meetup and meet someone and then give me an opportunity. Well, that's another recruitment story. Yeah, so really learned a lot from all the speakers here previously, and hopefully my sharing tonight can give you some insights and can help someone sitting in the room tonight. Okay, cool. Let's jump into the main content. Okay. Something about myself. I'm Gary Sung. I'm a senior software engineer working in Square, aka Block. No one actually knows Block in Australia. I'm running a meetup group called Frontend Workshops. We used to run monthly events that is trying to use different microfront technologies, TypeScript, GraphQL, trying to run in a workshop way to build in some projects. Because this is following this workshop way, so we have some challenges during the lockdown, so we stopped. So with the things recovering back, so we are thinking about to reopen it, so keep an eye on it. For myself, I'm a marathon runner. I finished 3 marathons in Australia, Melbourne, Sydney, and Gold Coast. For me, jogging itself is kind of like meditation. I really enjoy the moment. I think everyone should find a way to find yourself, and jogging is definitely one of my ways. And besides that, during my lockdown, I got 2 furry kids, which is Mango. Mango is a 4-year-old corgi, and Cherry is a 1-year-old toy poodle. They are totally different in sizes. Cherry is just 2K, and Mango is 15K. But actually, Cherry is always the first one trying to fight with the big guy. And yeah, so that's it. This reminds me that we should always step out of the comfort zone and doing some challenging work. So here I come and give the talk. Cool. Yeah, so tonight, I think I was given 20 minutes. I want to comprise the whole story of micro frontend into 20 minutes. That's challenging work. So what I want to do is by following a storytelling way about where we started and then coming into different approaches and why we pick up the approach and then jump into some live coding stuff. I know live coding kind of dangerous here because I know many people are making mistakes by live coding, but hopefully I'm lucky this time. And then we will talk about the next step, what we are, where we are, and what the direction is. Cool, let's start with the first one. Back to the history. Where we started, I joined the company last year. Why I joined the company? It is like a classic peaceful modelized team. We are building some services on merchant users. More specific, we are building a portal for merchant users. So you can imagine that a merchant logging into our system, they can do whatever, account management or order management, all this kind of stuff. It used to be a quite small team that everyone knows the whole context. So what I want to say is that at that time, it is following a single domain. The domain context is kind of small. But last year, the business is growing really fast. At that time, the company's name is still Afterpay. So it is growing really fast. We recruit a lot of developers. Maybe from the management level, they think that maybe we can, if we want to develop 3 times faster, if we want to build 3 times features, we need 3 times developers. That the conclusion is not that correct because it brings a lot of chaos by following this architect. The thing is the roadmap and the scope is growing really big that everyone is trying to understand them as a whole. But when everyone is trying to take the responsibility, it means that no one is actually know it, right? So we are putting a lot of PRs in the same code base. And this monolith and SPA, they are on the same repo. A lot of PRs, putting a challenge to the code review because no one actually knows the whole context. And then development becomes really hard because we got a single pipeline. And we can only, if you want to update just one model and see that in the production, you need to wait for the other models to be ready. It's ridiculous, right? You cannot bear something like that. And also, after it becomes a really large team, we got 3 times developers, then we jump into an international team. So we got more and more developers in different regions. like us, I'm working with some European friends, some friends from San Francisco. That becomes a normal pattern for us. And I was talking about like you know, communicate with different regions is really a headache, and you have to define the things really good, and then you can build things in an async way. So only that the things will work. Well, it seems that okay, the organization is growing really fast. The scope is really growing really fast, but the software structure is not doing any change. That will be the problem. So the conclusion is coming from organizations change first, and then jump into software's change. That's what I believe is in domain-driven development, right? So the piece of software should always reflect a piece of your organization structure. Then these two parts can reflect with each other and work pretty well. Then people may think about, okay, the next step will be, okay, microservice. That kind of becomes a normal pattern in the market because like people knows, okay, the normal list has so much problem, and then we jump into microservice. The reason doing that because the domain growing big, we divided that into different domains. Here to better explain the questions, I put that into several services. I cannot really share any real data, but let's assume that we are building machine portals. It has like order service, team management service, auditing service. These all three are separated out from a model list and becomes into microservices. By doing this, we achieve some benefits like, it is modularized and it is aligned with the sub-business domain, which means the team here, it may be located in Shanghai or in San Francisco. They know what they are doing and they don't need to know what others are doing. So they are only focused on what they are supposed to do. And they can use whatever they want. Compare with the model list, right? You need to comply with what is currently in usage in the repo. You have your own repo. You can pick up different technical flavors and to satisfy your specific requirements instead of like compromising with the whole company's decisions, right? By following the microservice way, we all know that we achieve all these kind of things. We can deployment independently. We don't need to wait for others. And yes, as I explained, we decentralize the governance. You can choose whatever you want. And we are hiding the implementation details from other teams. But these are all the benefits we achieve by coming from microservice. But the front end is still having the issue, right? After we divide that into several teams, let's say the team Shanghai, the team in San Francisco, the team like in Melbourne, we still have a big team that is building front end. How to solve that? Under this structure, we only have two ways. Either we have some team members, like for example, this team, they have some team members working on front end, and they all have some their own team members on front end, and they all committing to the same code base. That's one of the way. But the better thing is that you have to align with each other's choices because you are committing to the same code base. The other way is that we are building a really big front-end team, and we are aligned to the different team members to different microservice team and talking about what's your real subdomain, what's your business context is, and then combine together, get the requirements and combine together. So the team itself still suffering from like different regions, time zones issue. What about if we divide the front end, the big front end, into different service, micro front end, and then let the team, the whole subdomain team, build things end to end? That's what we want to achieve. So if we achieve this, we can really for this sub team, the building the requirements from front end to back end to everything you want, E2E solution, and then you can have the ownership of this subdomain. And the same benefits from microservice, you can have different flavors. For example, let's say that audit log page, it sounds like it's just like a single page. It doesn't need like a state management library. You don't need to care about the Redux. But maybe some other microfront, they are really big that you need to think about this way. So you can choose whatever flavor you want in your front-end code. Then doing this, the best benefits we can achieve is deployment independently. So which means that when we have some changes here, we don't need to wait for others to be ready. So in the ideal situation, the whole front end can better to pull the latest from all the UI and then work together with other micro front end. That's the things what we want to achieve. Yeah, so here we comes into the concept of micro front end. Yeah, so when we're talking about dividing a front end into several parts, actually, I think most of people here, you got the front end backgrounds, you may think about two different ways. The first way is dividing that from the UI, right? Let's say that if we have some UI like this, the left part is team management, the right part is orders. We can divide that into two parts and then assign this job into two different teams. They only knows team management and orders. This is by putting the micro front in the same view. By doing this way, we have to say that because it is on the same view, you have to think about how to communicate with these two parts, because there must be a reason for the users to see these two parts in the same view, right? You cannot put random things there. So normally, if you want to horizontally split your front end into two parts in the same view, you need to consider about, whatever. Take an example like this. For example, the team members is a list of team members, and then the orders is actually reflecting whenever you pick up different team members, the orders only display what belongs to this team member. So there must be some communication between these two. And the communication here means that actual work. So you are not actually build the domain boundaries between these two because it's still trying to communicate with each other. But to be honest, this like horizontal split is a valid case in the market because you see a lot of products like e-commerce website or some other things like they have this requirement and this is a valid case for micro frontend. But our team, we are actually adapting this way because, like I mentioned, we are building a portal. So you can imagine all the portal you used before, like portal itself is more like a navigation bar, and you click a different tab and jumping for different content. That's the things we want to achieve. So we are following this way. This actually splitting is built on the UI part. Building like from what the user can see from the UI. But actually, as front-end developers, you may think about, okay, code splitting is more like, it's more like how to split your JavaScript bundles, right? It's just like JavaScript files, no matter which framework you are actually using. I started my front-end work since 2011, and I was working with jQuery. And then, this is a lot of stuff coming up. But under the hook, they are still JavaScript, HTML, and CSS. So when you think about okay, divide that into two parts, under the hook, it's mainly about, what if when we launch this page, we fetch the JS bundle for this one and run that in our browser and display it. That's the main purpose. That is, I think that's the solution for every single micro frontend. So, yep. So by using micro frontend approaches, like I mentioned, that we are following this vertical split way. So the main idea behind that is something like you have a shell application, and the shell application is trying to use the routes to, you can use React routes or anything. You can point to different pages. As long as when you point it, you get your code base to fetch the JS bundle and display that in the UI. That will be successful. Actually, there are actually different solutions in the industry to achieve this purpose. This one is like lives for a really long time, which is iframe. Yeah, I see someone's laughing at it. iframe is quite old, but we are still kind of using it. It satisfies all the micro frontend requirements because, for example, imagine that you are putting a Google map in your web page. You're actually putting the Google map in the iframe. And you don't care about what's the implementation of the Google map. You just fetch that into your iframe. But iframe has a lot of drawbacks because it can, first of all, it cannot support a history object. And if the iframe itself becomes super big, makes the user very difficult to navigate and provides very bad user experience. That's iframe. The other one is web component. That's the new ideas. And in my last company, we were building things from web component. Web component provides something like Shadow DOM, which you can inject with your front-end frameworks. No matter which framework actually you are using, you are actually connecting your front-end framework into some DOM nodes, right? Web component can achieve that, can provide Shadow DOM for you to connect. But for using web component, the bad thing is like there's no kind of mature frameworks in the market. So in my last company, which is NAP, so we're kind of building our own bootstrap way of using web component to achieve that. Pays a lot of efforts on it. So for now, like in my current team, we are thinking about maybe we should try different ways by using some mature framework. So then we comes to this, like these two major players in the market, which is single SPA and module federation. They can both achieve runtime composition, and single SPA is something that is like basically from my evaluation, I think like they are kind of the same. But the better thing of module federation is that because it is kind of like a plugin from Webpack. So every project which is using Webpack, you can just upgrade your Webpack versions and just pick up these abilities. It's super straightforward. And for my case, because we used to have a legacy system dashboard UI, right? That is unfortunately written by AngularJS, not AngularJS. It's really old. And we kind of have the plan to deprecate it, but not instantly. We have to do it step by step. Then what we can do is like maintain it for a period of time. When you build some new features, hopefully this AngularJS project can point to the new features and display on it. That's external requirements we want to achieve. And that AngularJS project is bundled by Webpack as well. So that's the reason we pick up module federation. Yeah, so for module federation, like I mentioned, it's just a pure plugin. It's a plugin for Webpack 5. What it does, it allows JavaScript to dynamically run code from another bundle or build. Like you can fetch whatever the bundle, no matter it is located in different services, you fetch that in your local and run that in your current code base, which is in your current like running environment, which is the browser. So for module federation, there are some key concepts, which is host and remote. Host is kind of the container. So you can imagine that as a shell. So when you build the application, right, like I mentioned, right, you build the shell first. It is like an entrance for your user to jump into the application. The remote is like the micro frontend. So here, like this is like a remote repo, and we cannot call it repo. It's a from micro frontend. You can fetch that. I think the pure talking is not very straightforward. Let's jump into some small demos. Yep. So here, is the font size okay?
No, go ahead.
Okay. Happy now? You need glasses. Okay, cool. Okay, thank you. Well, this is a simple example coming from the Model Federation's examples repo. I just made some small changes. We got two applications here. Application one, what it does, let's look at the source file. It has application file, which has a navigation bar. Navigation bar is coming from local, so it's like pure navigation. And it has suspense, switch, routes. It's just rendering the routes based on what you click from the routes, right? That's what it does. And application two, what it does. well, I just comment this out. It does nothing. Like from the application, it does nothing, but it has a component called about page. The about page really renders something. Okay. So what I want to do is I want to run this as a shell, and then when I click into the about page, it show this component into application one. So because I'm kind of like running two projects in this folder, I'm using look at the root folder. I'm using Learner to manage multiple packages and hosting them. Yeah, that's all. So basically, I've already started with the application, and it is actually running for both application one and application two. And then let's jump into the browser. Yeah, so I'll just refresh it. Look at this, because we are using hash routes. So as you can see, this is coming from application one. And the route itself, this part is also coming from application one. But when I click about, it is actually jumping into application two. So which means that it is actually fetching this JS file to application one. How do I achieve it? So when we look at it, let's look at them one by one. When we look at application one, right? So it is just a normal React application if you look at the Webpack file. Other things you might be very familiar with is just like a normal configuration of Webpack. But there's something different here, like we are using a different plugin. But that's all, just a new plugin. The plugin itself is actually introducing model federation. And you need to specify the application name and file name. What is this? This is like when some application is actually using your application one's expose, needs to load this one first. Okay, it doesn't really matter. And then we jump into remote field. As we can see here, we tell application one that we are expecting something called application two that is coming from this pod, from this file. Okay, so application one actually knows that who is running in the background and under this pod. And this expose means like what kind of component you want to expose to federation. And shared here means that model federation can provide this feature. Like you don't need to imagine that you're actually running to like a front end. One of them is coming from AngularJS and the other from React. Or you may run two React applications that is from different versions. But by specify from application one, they are like, I want to share the React version here. So in the runtime, I don't need to, when I load application two, I don't need to care about its React version. I just load React once from application one. So the same thing here is for React DOM. Okay, no magic. Then for application two, we look at the same thing. Yeah, no magic thing. Okay, for application two, we are actually telling application two that we are using something called application one. But I'm pretty sure here that in application two, we are not actually borrowing anything exported from application one. So I think I can comment it. And also here, expose my about page component to model federation. So which means that others who is consuming application two can actually use it in runtime. The other things are the same. So from this configuration, what we really did is like expose this to model federation. And then in application one, right? When we look at the navigation bar, application page, local routes, and we can see we are putting a route here. We tell the routes that when user like inputs like about/about, jump into this component. This component is actually coming from application 2. Yeah. So that's the basic logic. So very easy configurations between different projects, and then you can kind of link them together. It is really powerful. You can imagine you are not exposing. This is like a pure component, right? Expose it to it, and the component itself can have its own state library, state management library. You can actually expose really heavy things to the shell, and also you can expose whatever the utility functions to it. And this is all happening in the runtime, which means that, you know, people may think about, you know, to compose in different JS modules, we can use npm module, right? But npm module, you're pulling something from the library that was achieved from building time. The runtime benefit is like you can always point it to different URLs, and then you achieve the same thing. Imagine that application 2 has a new version. You just need to tell application 1, okay, now point it to the new version, and you will get it. Very flexible. Yep. So that's the basic logics, like basic usage of module federation. And we still get some things to think about. Because we've already divided into macro front, how to provide a consistent UI behavior. That's the questions. From us, we are using our own component library. So that will be another problem. So everyone is actually consuming that component library. How about the unit testing? So as I showed, right, you can see that when you are building the project, it's pretty like you are building things in a traditional SPA. It's the same thing. So you are still running your own unit testing. How about E2E testing? You are kind of like testing that from the beginning, from the shell, and then jump into your logics. For pipelines, for each macro frontend, it has its own pipeline. You can deliver whenever you want. You don't need to wait for others. Okay, so that's kind of what we've already achieved. We actually got different teams. Like US team is kind of building a thing. Shanghai is building another thing, and we are working in Australia, and it's working perfect at this moment. Next steps. So there are still a lot of things that we need to think about. One is like a macro front-end versioning. We actually haven't achieved it because all our macro front is, for the current status, all our macro front-end are static, like client-side rendering. So we are kind of pushing that into S3. But we can have some mechanism in between, like when you define the different macro frontend URL paths, you can fetch that from like a JSON file and specify which version you want to point to. We can achieve that. It is achievable. The other thing is for gracefully. Like for the current status, we don't have a way. We can provide a way, but we don't have it now in our code base to, you know, like when the front end, for example, like application 2 is failed, so when we jump into application 2, it shows a blank page. Sometimes it's some fails, some errors is easy to handle. You can use red boundary to catch that, but some of them is quite hard because when you're fetching the JS bundles, if we cannot find the JS bundle, it will not for graceful. Even red boundary cannot catch that. That's some issues we are facing and we are trying to finish, trying to improve. Better E2E testing, like our current E2E testing is based on Cypress and it is testing on QA environment. We don't have the mechanism to, you know, when you merge the code, it's rather testing this stuff. We haven't achieved it yet. But yes, so that's what I want to share tonight. Thank you all. Any questions? Go ahead, please.
Just curious about in terms of API and how you're querying API, do each macro frontend do their own networking, or you use something like GraphQL and Federation, for example, for each API, or what are you considering?
Yeah, so it's something like this. So macro frontend. So basically, Well, you can do whatever you want. The thing is, like for our current status, we are kind of using a whole BFF, but the BFF is more like API gateway. It is just a pointing to different service, and it's not like a fully functional BFF. But when you fetching the microfront, the service, including BFF behind the microfront can vary. Like it really depends on your subdomain. Like for example here, all the UI can connect it with its own BFF. And its BFF is actually connecting with maybe like other service has like multiple services and you can do whatever you want. So that's the thing. We used to, the problem here, like having a whole BFF is that you kind of cannot take the ownership of the BFF part. So we used to, in my last company, we used to have like a very big BFF that is surviving, that is using GraphQL, and it is surviving like suffering like several frontend. But the thing is, the BFF layer, the team who is maintaining that becomes very hard because you need to understand each microservice, and then maybe it's the best time to move into like GraphQL Federation can solve that. But when you move to GraphQL Federation, it's kind of like you have multiple BFF. Yeah, that's my understanding.
Thank you.
Thank you. Yeah, go ahead, please.
So if you have a micro front end A, app A, and app B,
Yeah.
they have a mutual dependency that both happen to use.
Yeah.
As the user is navigating your overall site,
Yeah.
will they end up downloading the same dependencies twice?
Yeah, so no, the short answer is no. Yeah, you can specify to share the dependencies between different micro frontends. So which means that when you start like what I did for application 1, trying to share.
Is that a manual opt-in process though? Like
Yeah.
if it's a 3 layers deep dependency in the 2 graphs?
Yeah. Sorry, can you repeat that?
So what if like you have a React app A and React app B, and
Yeah.
you think like 3 layers deep, there might be a hefty mutual dependency. Like you can't necessarily manually opt in that shared like bundle for everything deep in the graph.
Yes, you are right. I think so. The nested routes there, you cannot specify that from the configuration. Yeah. That's a good question.
If there was something that was really big, as a dependency of a dependency in both apps, and you wanted to manually opt into that shared cache or bundle for both front ends, is there a way you can kind of hoist it up out of those 2 graphs and manually declare it, even though it's used fairly deep?
I'm not sure actually. Yeah. Any ideas?
Okay, so you could declare like
Yeah, go ahead,
A
please.
concrete example might be inclusion of font awesome and all the graphics that get included in that,
Yeah.
which is substantial on slower connections, that's for sure. So
Yeah.
how would you go and say, oh yeah, I want font awesome, this particular version across both of those, and just one download?
Yeah, but by specifying that from here, like you just when you initiate the shell, it is downloading the font awesome for this version, and the other micro frontend will just use it.
Go to the webpack config. I think that's where you declare to share stuff. Is it still not something that?
Yeah, okay, welcome. Yes.
So what's the share stuff?
Yeah, so basically all the shared modules should be configured here. Like for the font awesome stuff, if you so because shell itself is not actually using it. Let's say that maybe micro frontend 2 and micro frontend 3 is both using it, right? So when you load micro frontend 2, it is downloaded once, and the micro frontend 3 will use it. Or the user may jump into micro frontend 3 first. It will download the font awesome first time, and then micro frontend 2 will use it. So it depends on who is actually loading that first.
It's actually discouraged because it couples the applications together again. So you can really update your React version in one of the micro frontends if it's shared across all of them. So I think single SPA, the design principle is that you don't have any libraries in the shell.
Yep, go ahead, please.
You've got the Webpack config here directly. Can you use module federation with Create Reactor?
That's a good question because for Create app, from what I know, you need to export it out because you cannot directly touch on that because Create app is actually hiding the Webpack stuff. Yeah. Yeah. Yeah, reject. Yeah. Yeah. Yeah, you first, please.
You can go first because I just lost my thoughts.
I was going to ask if there's any answer to like type checking across the boundaries at all. Is that non?
It's already working with TypeScript already. You can define all the exports in a central place, and yes, that's what we are using for now.
If the different apps are in different repos, and you're in the host app.
Yeah, that's a good question. Like the reason why we are using here because like in my project, it's because we got different folders, different micro frontend that can actually share the same TypeScript file. But yes, that's a good question. The next step is should be sharing that between different repos. But we are not actually finding the way. Yeah. Yeah.
What you can do is you can actually use TypeScript modules, and what the basically does is it actually creates a distribution folder. It actually separates the visual.txt files for all of your assets, and then you can essentially package that up differently in that same sequence folder and share them amongst your various different projects or your repos.
Yeah, I don't follow it up, but I think it's a good idea. Yeah. Thank you.
The dependencies, I think I know the answer. Are they runtime dependencies or build time dependencies? And can you swap between those two models? So for the remote entry.js file, for example.
Sorry, I didn't.
So you've got two apps.
Yep.
And you've got the remote entry, which provides the entry point. And I'm assuming at build time,
the remote file is only actually providing the connections. So let's say that here, right? So when we look at our application, right? So let's look at the network tab. Oh, this is super small. We already know that we got two micro frontend running as a background, and when we jump into about page, nothing happens. Yeah, I just refreshed the page, and we got some remote entry. This is kind of telling the shell that okay, we got some micro frontend that is located in this place. It is not actually fetching anything. But when we jump into the about page, it is actually fetching. Remember, for this JavaScript file, it's fetching from here. So I'm not sure if I answer your question. It is like, yeah.
You have.
Yep.
Can you build a flat version for a headless site, for example? That has all of your components bundled in HTML, JS, CSS, ready to get served up just off a static service?
Flat version just for service. Yeah, never tried that. Yeah, that's a direction. I'll try that. Thank you. Cool. A lot of questions. Yeah, one by one. We got another speaker talking about micro frontend as well. So maybe save some questions for him. Yeah. Just kidding.
It goes into the same vein as this question as well. It's like, have you done any experimentations with server-side rendering?
We are not doing that, but from the model federation examples, like they can support it. But be careful about like they can support server-side rendering, but they just released a new feature for model federation that is supporting Next.js. That's kind of like a paid plugin. So anything related to Next.js is kind of paid for model federation, but the other server-side rendering ways, like they can support it. Yeah, that's what I know. So short answer is yes, they can achieve it. Yeah. Go ahead, please. Yeah.
Yeah, can you actually do things like React context between two
Yes,
assets?
yes.
So it will pass down.
Yeah. So for my current project, we are on the shell side. We are putting the user's authentication status, and we are putting the analytics functions, helpers, and passing that to different microfronts by context, React context.
Do you have to use the React symbols and things for that to work?
No. It is. That's a good question. yeah, that's a really good question. I'm always using this singleton thing. Yeah, might be some problem because if they are loading different versions, right? They may have different APIs. Yeah.
Probably.
Yeah. Cool. Thank you, everyone. Yeah. Yeah, a lot of questions and gives me a lot of experience, and I got some homework to do. Thank you.
Hey guys. So I'm going to give you guys a minute to settle down, and then I think we'll get started, if that's okay. Okay. Well, I guess that's the bell. We'll get started. Hey guys, it's really good to see all of you here. It's been a while since I've seen such a large crowd, and especially for something technical, which is pretty phenomenal and fantastic. So thank you all for being here. And it's good to be back in the limelight, honestly. A little bit about me. So my name is Mario Swartz, and I am a full stack developer. But one thing that may not be apparent is the fact that I'm also an embedded engineer. So I'm an embedded developer. There's no such word for that. Somebody who's a full stack engineer plus embedded. I don't think there is such a thing like that. I work for a company called Hack Hunter, and I forgot to bring a little device that we're actually sort of currently producing. I got a colleague in the audience over here, so we work together and we do some really good React work. Okay. So today what I'm going to be discussing is I'm going to be discussing a little bit about actually putting a React application on one of these devices that you see over here, on an ESP32. Okay, it's pretty remarkable. Now, what's interesting is that according to Gartner, right, there's going to be 7 billion products connected to the Wi-Fi by the year 2025. So this is definitely an interesting space to watch out for. All right, so when we create a React application, okay, when we deploy it, it normally winds up in a place like AWS or Azure or some place like that. And it lives in a data center like this, so you've got some sort of SAN, like a LAN, large area network, or large storage devices, or hundreds of CPUs, probably gigabytes of RAM. And these things take up office floors. They're huge. And your React application sits on just a slight sliver of, or essentially interdisposed amongst multiple devices or multiple machines like that. Today, we're not going to be doing that. We're not going to deploy it on that. What we're going to be doing is we're going to put it on a device that's essentially the same size as a 5-cent piece. And you might ask, why on earth would we want to do that? Well, the first answer is because it's cool. Okay, it's just, why not? It's phenomenal that you can do that. But more importantly, what it does, right, is it actually gives you, as React developers, right, an interface and a mechanism to directly control the chip, which basically means you as a React developer can now start interacting with the physical universe, which is quite cool. Okay, and if you want to know the architecture as to how we do this, it's quite simple, all right? These ESP32s, or these little microcontrollers, have a capability of having a web server. So what we have at the bottom is we've essentially got some C code, which basically lives in essentially Flash. Flash, think about it like a hard drive. And then we've got the React code, which is essentially a static bundled site. And then we've got essentially an application layer on top of that, which does some HTTP routing. So We've got some page routes, which basically serve the static bundle, and we've got some API routes that basically directly interact with some peripherals, such as light bulbs and stuff like that. But in terms of this particular web server architecture, you kind of look at that and kind of say, hey, that's not new. Well, yeah, it isn't. We're doing exactly the same thing, but the only difference is now we're doing it on a very small device. So this is the introduction to the particular microcontroller that I'm using. This is an ESP32. It is one of my favorite microcontrollers. This sort of thing that you see on top over here is actually a can. It's a metal sort of fixture that sits on top of it. And if you take that off, I've got some device over here which you wouldn't be able to see from up here. You've got two chips underneath there. You've got essentially the ESP32, which is the actual brains of the thing. Think of that like the CPU. And you've got this thing which is flash, and your React application is going to go sit inside that little sort of chip over there. Now I'm going to basically just go through some stats, and I'm going to compare them to my machine. So my machine's a 4-core machine, 8 virtual CPUs. This has got dual cores, so it's actually got 2 CPUs. All right. My machine's got Wi-Fi built in, and you notice that they've got this little sort of squiggly line at the top over here. It's a bit hard to see in this light, but there's this little sort of squiggly line at the top of it. You can see that over there as well. That's actually an onboard antenna. Oh, sorry. Oh. That's an onboard antenna, and that basically means that this thing has native capabilities to connect to the internet, which gives us some interesting use cases. All right, this is where it gets really interesting. Mine's a 16 gigabyte machine. This has got 320 kilobytes usable RAM, so not a lot of RAM, so you've got to be very careful how you manage memory. I've got a terabyte of hard drive space. This thing's got 4 megabytes of flash. Okay, so 4 megabytes, that's your limit. Okay, but one thing that this thing does have is lots of peripherals. Okay, if you just give me a moment, I'll just get one here so I can show you. Sorry about that, I should have had that ready. Okay, so, right, so this is the can that you see over there, right, and then essentially you've got these sort of pins that basically fall out to these other pins over here, these external ones, and over there you can put motors, and you can put lights, and you can put sensors, and you can basically control the weather, you can do whatever you want, okay, and as I said, underneath that thing is essentially these 2 chips over here, which you can probably not see at the back, they're very, very small. First one being the ESP32, the brains of the operation, and the second one being the flash, which is essentially where we store everything. These things are also very, very low power. And as you can see over here, I've got one running on a little 3.3 volt battery. So yeah, they basically can last for a long time off a battery. So there's the ESP32, there's the flash. So some of the use cases that we would want to actually put a React application on one of these microcontrollers. Why would we want to do that? Well, it gives us direct interaction for remote controls. So here we can basically go ahead and actually create a user interface for a drone or a robot arm or some toys or something like that. That's one particular use case. Another use case is active monitoring. If you're trying to monitor something that is constantly online, like some power plant or something that is critical, and you want to basically make sure that it's active monitoring, active alerting. These chips can basically have the sensors in place to be able to monitor it, and then you can essentially log into this thing, into the React application, and actually monitor it in real time. And then the other thing that these particular chips are very, very good at is essentially low-powered activity. In other words, what we do is we actually make them sleep for the majority of the time. We wake them up periodically, like once a day, or once every couple of hours, and then we send a burst of information saying, this is the temperature, this is how much water was consumed, this is the level of fluid there is, or whatever it is we're trying to measure. And then the thing goes back to sleep. Now, obviously, while it's asleep, it's not a very good web server. You can't get to it, okay? But in setting up the actual device, how often should it communicate? What are the thresholds? And so on and so forth. You can create a React application, and you can essentially create all the configuration that you want to for it. And that is another good use case for creating a React application on an ESP32. So I'll give you a quick demo over here. Hopefully the demo gods are kind today. All right. So what you're actually looking at is, if you have a look at that URL, I don't know if you can see that, it says myesp32.local. So that's actually me going over the network, okay, directly to my ESP32, and I'm using my phone as a hotspot. this thing actually can act as both a station and as well as an access point. So if I don't have a hotspot available, I could actually set this thing up to be an access point, and I can dial into it directly with my PC, as in, go into networks and find me the hotspot, or find me the network. Of course, if I do that, I don't have internet access, because obviously, my ESP32 doesn't route to the internet, right? But in this case, because I'm using a hotspot, I can route to the internet. Okay, but I don't really need to in this particular case. But anyway, this is actually dialing directly into the chip, my ESP32.local, and you can see it's returned something. It says basically hello world. All right, we'll have a look at the code in just a bit. Now, I'll just go through to the next one over here. So on that little chip over there, can you guys see that okay? All right, on that chip, there's a tiny little light. There's an LED. If you can't find it, I'll switch it on for you here, and it should go on. So, so then you can essentially switch it off and you can switch it on. You can see the speed is not too bad, okay? And that's using HTTP requests, okay? All right, this is also using HTTP requests, by the way. All right, then I've got this push button, which is gonna be a little bit tricky because I have to get my hand around here. So the problem with HTTP requests, obviously, is that this client, being my local machine, has to basically initiate the communication. It has to go out and basically invoke it and say, hey, what's the deal? But if the chip wants to communicate to the browser, how does it do that? Okay, it's a bit more tricky. You can use something like polling, but in this particular case, we're using WebSockets because the ESP32 has built-in WebSocket capability. So if I go ahead and press this button, which is falling out. That's not gonna work. Okay. I'll have to basically, I can show it to you afterwards if you like. I'll just basically find it. There's something else I forgot. One second. I'm gonna bring my old back. Okay. Yeah, I wasn't super organized when I came up here, so please forgive me. Let's see if I can fix this. Thought I had everything ready. Here it is. My magnet. Okay, so the ESP32 has a built-in magnetometer. I'll basically see if I can fix that other thing just now. So this can be used as essentially a location. So if I go close here, nothing happens. And the reason being is because it's actually polarized, so I have to turn the magnet around. Okay, so you can see here, basically if I get very close to it, it gives me sort of a value like that. And then if I move it away, it goes further away. So it gives you some sort of proximity alerts, okay? And the next one that I want to basically just quickly show you is a server, and this is essentially quite cool. This is also using some WebSockets. So I've got this little motor over here, okay? And you can see it's pointing in that direction. And as I basically slide this, you can see it's pretty quick. Yeah, that's also using WebSockets. So, yeah, too bad about the button. Maybe I'll flash it a bit later with another onboard button. That might be easier. But let's get back to the slides because I don't want to run out of time. So if you want to know how to program the ESP32 and you're interested in that, obviously you need to know the C code. But I got you covered there because I've actually written a course, and it's an online course and you can go to it. And yes, I'm flaunting my own, yes, I'm advertising my own course. But you can go ahead and learn all about the ESP32 there. It's got like 20 hours worth of video content. And it's very well liked and very well loved throughout the community. So go and check it out if you want to learn a bit about microcontrollers. Okay. But let's have a look at the recipe as to how to get the ESP32 or React application onto this thing. Okay, so first thing, you've got a plan. You've basically got to figure out what it is you want to build. Do you want to build a robot? Do you want to build a drone? All of these things are completely possible with this tech. Okay, then you've got a prototype. You basically get a board like this. You plug in a couple of sensors. You plug in a couple of different things. You go online, you find a couple of articles as to how to use this stuff. It's not hard. It really isn't difficult to wire this stuff up. And there's plenty of examples out there. All right, then you configure the chip. And you look at my course in terms of how to do that, but essentially what you need to do is you need to allocate enough space to put the React application on there. Right, then you program the chip, which basically means connecting it to the Wi-Fi making sure that you've got a good way to basically credentialize it. There is basic security built in if you guys want to go TLS, if you guys want to go and use dynamic DNS, yeah, totally fine. You can go ahead and do all that stuff. Okay, but you basically got to connect to the internet or connect to the Wi-Fi. You then basically set up some endpoints. Okay, and I'll show that to you in a moment. Then you create your React application. Okay, and we've all done that, I'm sure, at least once. And then you flash your chip, and you're done. Okay, so plan in accordance with the use cases. Prototype with a basic circuit. All right, then configure the chip, and one of the more important things is essentially you're going to partition the chip to basically make sure that you can actually allocate space for your React application. Then you code your chip. You connect to the Wi-Fi, create server to your endpoints, create wildcard endpoints to React server. Okay, so here's some C code. So here, I'm pretty audacious, basically standing up in front of a bunch of JavaScript guys and giving them some C code. However, I must say, right, that essentially if you look at this, if you've never done C before, right, you'll be very much calm because JavaScript is based off C syntax. So it's very, very similar. All right, so you know what a function is. You can see the end of, you can see what a declaration is and so on and so forth. But the thing I want to basically put your attention on is this thing over here, this little structure, okay? Structure is pretty much like an object in JavaScript. It holds some data and it's got some properties. And you can see over here that essentially it's got a URI, which is basically API hello world. It's got a method, HTTP GET, and it's got a handler, which is essentially a callback. It doesn't matter whether you come from Ruby, it doesn't matter whether you come from Django or Express from Node.js or .NET MVC. This is pretty much universal. You always basically have these same parameters, and you basically, if you understand HTTPs, you can basically program this chip to be able to do the same thing. And then you create your handler, and over here we can basically see that we get a request object. That's a big surprise. And then from there you can basically see what the content type is, you can see what the length of the content type is, you can see what the method was, and so on and so forth. And then you can generate a response. And that's exactly what we're doing here. Of course, we can also basically say, is WebSocket true? And then we've got WebSockets, which is pretty cool. All right, then, of course, you create your application. All right, and if you've done any sort of React application, this is no stranger. This is going to be the easiest part. One of the cool things that you can do, though, is you can actually use proxy. So I know Vita, it's pronounced Vita. Vita and Create React App both basically have proxies built in. And basically what that means is that when you basically try to get through to the backend, which in this case is the React chip, right, you use a local /API, blah, 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 and the framework takes care of actually binding that to your chip, which basically means that you have that whole sort of instant gratification as a developer. As you make changes to your React app, it immediately basically updates and shows. Obviously, if you make direct changes to your backend, your chip, you need to flash that. Oops. So when you're actually considering doing this, right, you might want to consider some building frameworks that are out there. Now, you've got 4 megabytes of flash, of which you want to basically give at least 1 megabyte to your C code. So you've got, let's say, 3 megabytes left. But honestly, you want to try and keep it within a megabyte, okay? So this is because you might want to do things like over-the-air updates and so on and so forth, and you want to keep that space for other things. So you want to basically try and maintain the application into 1 megabyte. And I find this quite interesting because this is essentially a little sort of thing that I had to go through, and people don't really talk about this a lot, right? So sometimes it's not only about the size that you actually see when you're looking at the actual page that gets downloaded, but it's about the size that gets bundled. And specifically for this use case, we care about what size the bundle of that application is. So here we've got a couple of them. Gatsby is a very popular static framework. It produces a hello world basic center, no extra things at 1.1 megabytes. Next.js, which is my favorite framework to use, unfortunately I can't use that. It's 6.34 megabytes. However, what's interesting, right, is that if you have a look at SvelteKit, which is kind of on a similar sort of basis using Svelte, that produces a 60 kilobyte package. So that's usable, but that's interesting. Right, Create React App is actually phenomenally large for what it does. It's 0.5 megabyte, okay? And it's quite slow in comparison to the next one, which is Vita. Vita is phenomenal. If you haven't tried it, I highly recommend you go and play with it. It's really, really good, okay?
It basically is a command line utility that will allow you to basically choose which framework you want. You can choose Svelte, Vue, React, whatever. And it really works very well. It's incredibly fast in terms of development speed. And you can choose whether you want TypeScript or whatever, and it basically just gives you everything you want right then and there. All right. If you basically choose React, it gives you a bundle size of 136 kilobytes. So you're well within the limit, and essentially you've got plenty of space to produce your own application with it. However, you can go one step further, and you can also use Preact. Has anybody ever used Preact before? Yeah, a couple of guys. Preact is a very small, lightweight version of React. It's very similar. It's got the same APIs, built by a couple of other guys who kind of thought they could do it better, and they bundled the size down tremendously. So that is another option. Okay, so that application that I just showed you just now, and I'll see if I can actually flash it for the button as well. That's basically using Preact. All right. The only disadvantage of using Preact is that it doesn't play nicely with all packages out there. So you saw the graph that I used was one that does play nicely. You can actually get a lot of things are compatible, but you've got to be careful because some of them just don't work well. Okay, so let's have a look at some React code because that's why we're here. Okay, so I want to basically show this to you. So if you can imagine, right, we had a look at the C code, and all that was basically showing us an HTTP server. So this is the React code. This is the hello world. Can you guys see that at the back? Yeah. Okay. Should I zoom in, or is it okay? Okay. Maybe you can get the lights, maybe? Is it possible? No, I can't remember how to zoom in. Let's see. Control plus. No, it'll be FN control plus in this case. Nah. How about we just do F1?
Once you can go in presentation.
I'll just go zoom in. There we go. How's that? Better? Cool? All right. So have a look at this. Really, really complex, guys. Hello world. It's basically got a use state. It's basically got a use effect. It's fetching hello world. It's basically getting the text out, and then it's displaying that text. Now, what is interesting, yeah, and when I said really, really complicated, I was kidding. Okay. What is interesting is you'll notice that this is not looking like normal React code because it's got some funnies in there. It's got things like alert success, blah, 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 blah. And that's because I've also bundled in, top of this, I've bundled in Tailwind, and I've also bundled in Daisy UI. So you can basically, as part of this whole stack, you're not limited in terms of frameworks or codependencies that you want to basically use. You can use anything you want. Have you guys seen Daisy UI? No? Daisy UI is pretty cool. So, by the way, who over here has basically been introduced to Tailwind? Yeah, a couple of guys? Okay, so Tailwind is essentially a CSS framework. The problem with Tailwind is, even though it's fantastic, is the problem with it is that it's very verbose, right? And it basically produces very large, segments of HTML. So Daisy UI is essentially a component library that sits on top of Tailwind, and it basically gives you things like buttons, and it gives you, the drop-down list and everything else that you require, but it's essentially a Tailwind-based library. So something to check out. It's very cool. So yeah, so inside this React application, inside the static bundle, I've got a charting library, I've got Daisy UI, I've got React, and it's all sitting inside that tiny little 4 megabytes or tiny little 1 megabyte of flash. Okay. And as you can see, very, very straightforward. If you know how to basically use standard fetches and standard pushes and posts, you're there. It's very easy. Of course, when it comes to WebSockets, it's a little bit of a more challenging arena, but not that difficult. Okay. So let me just show you that quickly. So here is the push button one, which I'll see if I can get fixed. And you can basically see that we create a WebSocket. I'll just collapse this over here. You create a WebSocket, okay? Then essentially you can do an on-open, and you can send something through to the server. Okay, and then essentially you've got this on message. And that basically means that when the backend posts something to you, you get the event, you can basically pass that to JSON, and you're pretty much all good. You can do whatever you want from there. Okay, and there's your React code, very simple. Okay, yeah, so that's basically that. Okay, so there's something that I've been thinking about. I just want to sort of, just gauge this guy with you as well. So there's, potential space here for community to basically jump onto a project whereby we could essentially have modular hardware that comes with an API. So if you guys are not interested in basically writing your own API endpoints, we could effectively just say, all right, well, here's a couple of LEDs, or here's a couple of buttons, or here's essentially a drone, or here's a toy, and you go ahead and basically figure out how you want to present it. I'll basically give you the documentation, the endpoints, the APIs, and everything else like that you need to say, here's your video feed for your drone, here's your roll pitch, your up, down, left, right, and go ahead and basically produce the React application of your dreams. So something to think about there. Of course, this would have to be modular. We'd have to basically consider things like package managing and so on and so forth. A common API format, you'd want it all basically sort of standardized. And of course, it would have to have excellent documentation because community projects don't work unless they have good documentation. And then I also am a firm believer in open source and freeware, okay? And I do believe that people should essentially put stuff out there for free, but I'm also a believer that people who work hard should be rewarded. And I don't believe that guys that slave over 2 to 3 hours a day should never ever get remunerated. So you definitely want to put in some sort of marketplace or some sort of mechanism for developers who are actually putting in effort to actually get remunerated. So that's kind of what I'm thinking about now. I haven't really fully thought it through, but I think there's good potential in this space. So yeah, that's it. Okay, thank you very much. I hope you enjoyed that. Yeah. Yes, questions?
Firstly, thank you. I've never had a clear understanding of micro front ends, and this is great. I now understand what a micro front end is.
Not quite the same thing.
But it sounds interesting, and if I wanted to start playing with the ESP32 chip,
Yes.
What's a good retailer to go through? How do you recommend buying hardware like that?
Good question. So I just would say so that the guys over the microphone can, well, the guys that aren't listening to this audience can hear it. The question was, well, how do I basically get one of these ESP32s? Where can I source them from? How much do they cost? And so on and so forth. The answer to that is very simple. You buy them on AliExpress for under $10. Okay, they're like literally the cheapest chips. Literally. Okay, you buy them on AliExpress for, most of the chips that I've got here are essentially $5 each. Okay, you can buy them very, very cheap, and sometimes you get bulk sales, sometimes you get deals, etc., etc. The only problem is, of course, you have to wait because it's AliExpress, but you can also get them on eBay, but a little bit more pricey. You can get them from Amazon, but of course, you're spending about $15 a chip there. So if you're willing to wait, AliExpress is definitely the way to go. And then once you've got them, there's lots of different frameworks you can program them into. You can program them in the Arduino framework. You can program them in something called, something that I'm basically looking at the moment. It's called Zephyr, which is quite interesting. It's essentially a cross-platform application platform for microcontrollers, programs STM32s, ESP32s, blah, 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 a whole bunch. But I'm using something called the IDF, which is the IoT Development Framework, the Internet of Things Development Framework. And that's essentially the official framework from Espressif. And if you want to learn how to do that, have a look at my course. I'll go through it with you in detail. So, yeah. Any other questions? Yes?
Did you have memory limitations with anything, with the C server or TLS or something like that?
So no. So there's actually an embedded TLS server built into the chip, and you can basically activate it. Okay. So yes, and you can basically embed certificates in there, no problem. So you can secure it, absolutely. Last year, during lockdown, I spent about a year creating a product. It took me a year to fill up 1.5 megabytes of memory in C code. Okay, and that was a very, very, I had a lot of stuff and I had full graphics application and everything else like that. Yeah, while I'm thinking about it and while I'm answering questions, I'm going to turn this beast on here so that you can actually see something. Okay, yes, any other questions? Yes.
One small one. You need a French sheet to say it's called vite.
Vite.
Vite, yeah.
My apologies. Vite. I get that wrong every time. Vite, Vite, Vite.
Vite is the new one.
Okay, Vite. Okay. Thank you for the correction.
That's all good. And the second thing, have you tried playing with Rust, with the ESP?
Yes, I have.
And how supported it is?
Oh man, I was starting to lose the willingness to live, honestly. And trying to get a little sort of blinking light to work was a pain in the butt. It's not impossible, but it is on the way, but it's very rudimentary at the moment. I think it's going to get better. Yeah. But yeah, it'd be interesting.
To that question, Expressive Systems have made a fork of LLVM for Rust, and they've got their own stuff that hasn't been integrated into mainline.
Yeah. But you can play with it. You can actually do experimental work with it. I have done some work with it. But my Rust is rusty. And then going onto an embedded system like this, it's quite a jump. It's like, wow. Yeah, I mean, you know, considering I've got a lot of other things to do in my life. You know, so yes. Any other questions? Yes.
When would you use this as something more broad across devices such as the ESP or whether when it is somewhere else so you have more space?
Well, yeah, so that is a good question. So I would basically say that this is very good use case for one-to-one sort of applications, like controlling a drone. Those are the sort of frameworks where you got the sort of the cloud solution with MQTT. And if you guys don't know what I'm talking about, message queuing, blah, blah, something. It's essentially a very simple sort of communications framework, and it basically allows you to talk to multiple chips. The thing is with those particular platforms is usually you're running a host of chips, or you're basically controlling a fleet of chips. You know, whereas this would be sort of more one-to-one, sort of direct communication with the chips. So yeah, it doesn't mean that you can't have both, actually, because you know, think about it. Like if you're installing, let's say for example, solar system, a solar panel cell somewhere on somebody's roof. Okay, you want the option to be able to A, set the Wi-Fi, B, basically set some basic parameters, you know, and do a whole bunch of stuff. And you can use the ESP as a web server for that perspective. And then once that's done, then essentially you can send the messages uplines to the other cloud services after that. Does that answer your question? Cool. Now, I just want to show you something quickly, guys. So this is the device that I've actually been producing. So what you're actually looking at is a React application, okay? And it's touchscreen, okay? And what this actually is it's giving you a list of all the Wi-Fi devices that are actually in the area. So this is actually giving you a list of all the access points. And it's going to be difficult for me to show you from this end because I have to sort of turn myself around. But I can effectively sort of pick on one. Let's go ahead and say, I'm looking at, let's say, I'll actually just press one. So basically, as I move around, that graph starts to basically decline or increase. And with that line, I can basically determine where it is. So it's there somewhere. Yeah. This device also basically checks it to see if anybody's trying to hack the network. It'll basically pick up Wi-Fi pineapples and basically, you know, deauthors, and it can actually track them as well. So if somebody's trying to deal with the network, I can actually find them. So that sort of thing. Cool. Any other questions? Is that it? All right, good. Well, I appreciate your attention. Thank you. I hope it was at least interesting. Thank you. I'll fix the button and then I'll display it over there if you want to see the button being this way. That's the thing. I believe that once you actually start mixing technologies, you get through
Okay, Arlene, probably maybe you can give the last session. Okay, shall we give a start, guys? Thank you. Cool. Yeah, the last section. First of all, I really want to thank you, Anita, or whoever in Kogan sent me from Gary, because I hate him. He did exactly the same topic as what I'm about to do, and he stole my thunder, and he still asked me to take a picture for him. but at least he answered a lot of questions for me, which I probably cannot answer. So we call it equal. Cool. So yeah, really thank you everybody joining me together in this session tonight. It's really good that after 2 years we finally have this face-to-face session, right? Instead of just a bunch of square blocks on Zoom or Teams that somebody not even turn on their camera. But to be fair, occasionally I do that as well, right? If that meeting is not that important and I really want to practice my dumbbell, right? I probably will turn off my camera as well. Cool, jokes aside, let's cut through the topic because I've been told that I only have 30 minutes, right? The topic from microservices to micro frontend. I am aware that we are sort of React Meetup, right? But it's sort of just the whole story that in the past years I've been in different companies, observed different environment, and look at how those organizations move from the monolith to either microservices or micro frontend. I just think it's probably better deliver as a whole story. Very quick introduction of myself. I'm Harry, the manager in mass media. Just in case you guys never heard of mass media, it's basically a mobile messaging service that help our customer to send message to their customer, which most of the time is a mobile user, right? And not only simple text messaging, we're also doing WhatsApp, Facebook, Instagram, Google Business Messaging. We have quite a few different sub-brands. Think about if you ever received a message from Coast, which actually sent from MessageNet, which is one of our sub-brands. Last year, we actually been acquired by Sinch, which is a telco provider or cloud platform solution provider based in Sweden. So formally now we are SMB division of Sinch. That's all for commercial, right? I'm not paid for that, so very quick. Let's get to the technical part. So as I said, during the years I've been in different company, I observed that almost every company have a monolith, which is quite common, right? So, back to 10 years, that looks perfect, right? So the monolith, you access to everything. You have end-to-end feature in the whole, just one single application. You debug, compile, deploy all your application into one box, right? This all looks perfect until it start blocking everything, like the evergreen, right? Which happens 2 years ago, I don't remember. Right, once upon a time, it's a fancy story that a big brand in Melbourne, which is sort of, I think it's top 3 in the domain. If you're really interested in which company staff, you can add my LinkedIn profile and dig my career path, give a guess. I didn't see the name here. As I said, it's top in the domain. It has one big repo. It has 1 million unit test cases. It has 45 minutes to build the whole project, as long as I modify one line, which is Java project, typically. One big pipeline, more than 4 teams, actively contributing to the big repo, and one release per week, which typically, like a release manager collects together all the leaders, all the senior devs together to say what we're going to involve into the weekly release, right? That's typically happens. We know what's the feature at that time, microservices, right? There's just one feature. We know it can help to cover all the modules, technology agnostics, etc. All good features. But we know why we want to do that. That means we will end up with a happy ending. Well, not really. You figure out why we want to do that. But if you don't have a clear answer for all the other W's and H, when to start, where to begin with, what to do next, who will own this project, and how to have a good plan, you definitely will fail, which exactly happens in that company. After 1 year, I left. As far as I know, that project has been canceled because it just cannot respond to quickly enough to the marketing change, right? Cool. What if, think about multiverse, what if it actually happens in mass media? What I've been told, never brag in the presentation, right? So I will make it this quick as well. We have a corporate legacy platform. We want to migrate to next-gen platform, which is horrible name, but it works. Actually, look at the silver box in the diagram. Basically, that's the monolith, and we serving XML serve all kind of different legacy protocols to our customers, sending messages. And instead of breaking that monolith, we actually developed a new microservice platform in parallel, and we're only serving the REST API to our new customers. And on the other, during more than 5 years of migration period, we actually developed a lot of API wrapper to help convert those XML or SOAP to the REST. On the other hand, we redirect all the traffic out of the monolith to the new platform as well. So in theory, from the beginning, we're actually holding all the traffic, so our performance has no problem. On the other hand, not only engineering team work on that, we have sort of product team try to make the gap between the two systems, and marketing team try to persuade this customer on board with our new platform, right? So it's a whole teamwork. So this is after migration. Typically, we have sort of this brand new sort of architecture for the AWS. DynamoDB, SS, SQS, EC2, ECS, everything that's suggested by AWS microservices concept. We adopted that. And we finally can retire the whole data center, which is on-premise data center in Melbourne. And literally, there was one period of time during pandemic. I'm the only person still got my fingerprint qualified to access that data center. I was so scary. Like I have to, there's something happening in the data center, I have to be there to fix something.
Your finger has to be there.
So eventually we separate everything and pipelines, reports, and we even on-call, right? So, well, on the other hand, we do later face another problem. There's hundreds of different microservices, and whenever there's team restructure, it's pretty hard to mapping which team should handle which service. Right? But that's another story, not today. So, like any sequel to a good movie, that there's a new villain, right? And that happens as well. When my mind got crazy, then I was like, okay, this is happy ending for the backend world. How about our, the like full stack and our front end? I want to give experience over there as well. So, the Hub, our mass media front end solution. By the look at it, it's a sort of pretty best practice UI, right? So like clear, concise, responsive, consistent, familiar, attractive, efficient, you name it. Anything we try to, we adopt every single UI, best UI practices. Unfortunately, behind the scene, when I dig a little bit deeper, I found there was still more or less hot. I hate to repeat this, but again, 3 tribes working on single repo. One daily release, which is slightly better than that weekly release, right? Different quality of codes across everywhere. What even worse is our release is often blocked by other teams, which because, think about this scenario that we're so excited with the new feature tomorrow, but then at the end of the day, we realize, okay, it's being totally blocked by other teams, one small functional test, and they don't really have a bandwidth to fix that, and we don't know the domain knowledge, and eventually being delayed. That's just horrible. And typically 9,000 test cases building on my local machine take more than 20 minutes. Multiple PRs causing all kind of merging conflicts. I can see all this red build on the build guide, which is horrible. And then I just stopped thinking that why we had that, fighting for all these years. We are so great microservice culture company, we still born this kind of monolith monster. But then later I realized, yeah, it's quite normal, right? You always start with POC, and then later you move on to MVP, right? Then you straight away think about phase 1 to 3. During that time, always there's priority war. You don't really know when should I do the A/B stack or pipeline or refactoring the code. And also even worse, sometimes you probably got technical capability issue as well. Okay, now we can move to the front end. Luckily, this time, to the monolith, we actually have this solution. If we follow the technology radar from Thoughtwork, basically at the 2016, micro front end actually reached the access level. Basically, it's sort of evaluation, see whether it's worth of try. And then 2 years after that is go to the trial stage, which basically means if you're aware of the risk, you can give it a try, right? Just be careful. 1 year after that, then we finally go to the adopt stage, which basically means if you feel that sort of can solve your problem, feel free to go ahead. It's have a bright future. So what is MFE? Look at the diagram. At the beginning, 10 years ago, we have one big red block, which is monolith. Later on, we separated to front end and the back end. And even further, we think about, okay, we now have the way to break the back end monolith into different microservices. And nowadays, we want to draw that benefit and lessons and to apply to front end as well. There we go. how actually to solve the problem that the company, top company in Melbourne, who experienced the failure before, how can we make sure this is a successful plan? Right, so so think about this way, right? So if you already have that, solution of micro frontend, if there's a new project come and you straight away go to the micro frontend way, that's fine, right? What I'm talking about here is more like how can we break this more or less into a new microservices? So there's a lot more to think about it. In my mind, there are three key factors to make this a successful migration. First one, technology solution, the priority, and then the owner. Of course, we're going to focus on technology solution, right? But we also will quickly mention the priority and the owner, and raise the two questions. And later, when we deep into technology solution, at the end, we bring back these two questions to see how to solve it, right? First, if you what is the priority? Who is the owner, right? If you're familiar with Eisenhower matrix, basically it's the quadrant that defines the relationship between the urgency and importance. So if you think about a project, if it's urgent and important, you probably want to do it now, right? If not that urgent, not important, you probably want to eliminate it. Okay. If it's the most tricky part is if this is actually very important, but it's not that urgent, what are you going to do? Also, who's going to do that, right? Think about team A, multiple releases a week. Happy, but they're happy with the dedicated release engineer to solve all this kind of overlapping issue. Team B, yeah, I don't really care. I have occasional releases. My team, more like team C, more like my team is sort of multiple releases in a week, but I'm pretty not happy with a dedicated release engineer time spent on that, right? Cool. Bear in mind that two questions. Let's go ahead with some technical solution, which is basically quite similar with what Gary told. That's why I hate you. Architecture. As I just mentioned, there's multiple brands, right? So, for different markets. And it's all hosted by the main container, which is the hub frontend. Then all those MFE, what we want is just sort of like plug it into that front-end main container. Think about the most, one thing I can think about the very familiar technology before is probably the Microsoft's DAR. So think about the main program, right? As long as we can clearly define that functional spec between the main program and all those DAR plugins, you can just replace the DAR with some even malware, right? That's why it's so not safe. But the story is different here because we have total control of the whole solution, right? And back all those micro frontend is all those microservices behind the scene. Look at the page structure. The blue box, big blue box, it has its own Redux store and it has sort of, logo and menu can sort of help us spot different brands. And then in the middle of the orange box with smaller, which is that our MFE frontend, and it has own Redux store. Cool. So how are we going to actually implement this, right? Do we really have a clear definition what is MFE? It's not really, because it's an emerging technology, right? It's changed all the time. Think about like 10 years ago, if we want to do this, how are you going to do that? Actually, it's quite simple, right? So you can just simply open your Nginx or Apache server configuration, and then you say one routing A and mapping to folder A, routing B mapping to folder B, which on those folders, you probably have a bunch of PHP scripts handled by different teams. And ta-da, it's all done. But I don't think anybody wants to do this way, right? It's not really what we want. So we got a couple of other solutions. The top right is the build time integration. I believe it's most of the company already done that, right? So it's not really something fancy or exciting because even you divide those modules into different teams, as long as you modify one line, you still have to rebuild everything. We do have another choice, which is sort of runtime integration. So look at that HTML script. Basically, you can have that sort of JavaScript to download those remote code and attach to different routing. And that sort of can either done, as Gary said, either done with iframe or web components. I personally did my like sort of 1 year ago with one of the sort of chat widget. I used the web component concept. Like think about you develop a chat widget and you want to deploy on one of our customers' website. You think about those 3D websites, right? and we hosted that chat widget in S3 bucket, and then we give one-line installation code, JavaScript code to our customers, and they can install into their website. Just put that one line into their header, and we automatically download that piece of code from our S3 bucket onto their webpage, and ZDEX 999, then you can have a floating chat box at the bottom right, and their customer can now expand that chat widget and start sending message. So that's all done, while sort of like an MFE, right? But this time is we want to maintain everything rather than half this from our customer, right? But the concept is quite similar. The annoying bit is just like in the movie about to have the Doctor Strange 2, right? So things gonna just go out of control. Easy, right? So you think about it, the whole big organizations, and with some not really standard way, and everybody probably want to do different ways, eventually gonna be messy. The good thing is we now have this game changer, Module Federation. By the end of 2020, Jack Jackson released his masterpiece, Module Federation, as the plugin in Webpack 5. And this plugin brought everything into a totally new level. We now can just literally include the remote component to the project as we just develop it locally. Now, without have to depending on sort of S3 bucket or web server, et cetera. Let's have a look how we actually achieve that. Instead of doing live code, I just some screenshot, which is super. And we already see the level down, so you don't miss anything. In the MFE, in the webpack.conf.js, you can literally just new Module Federation plugin, and our component is called message, sort of inbox messaging, right? We want to expose this whole module as MFE module. And we define a file name as sort of the entry point called remote entry.js. And we expose, there's some modules we can expose, like an app, we can map to source app, and the inbox item we can map to source inbox item, right? So that's done and sort of MFE side to expose, wrap everything to ready for the main container to use. And then we go back to the main container. Similarly, open the webapps.config.js. You can simply define a new Module Federation plugin. And you just say, okay, there is a module I'm interested in, which is sort of, I name it as messaging, and it's located at messaging at https://media.com.au, blah, 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 /remote-entry.js. And after that, you can just feel free to use that. And to use that, you go to the traditional way, not really traditional, like you can use the React or Lazy to actually dynamically import that messaging/inbox-item into the inbox item variable, and then later you can do a stronging with React suspend and use that. Quite easy and straightforward. That's why it's called masterpiece work, right? But unfortunately, when we're doing that migration, we didn't actually have that ready. So instead, we did a bit tricky way, like similar to what we just mentioned, that web components way. So literally, you can see that we actually constructed that MFE URL. At the end is the remote entry.js. And we actually developed the function load component. So basically what it does is loading that remote entry, grab the piece of code behind the scene, create an element onto the hub frontend and attach everything onto that element. So sort of a different, sort of typical web component way to implement this MFE, and then load everything onto that dynamic component, and then we can use surrounding with React.suspense and using that to initialize the whole MFE component. So I wouldn't suggest use this way because that's just before we have that. So of course, if you go ahead later, you probably want to directly use the Webpack that plugin Webpack 5 way, right? Cool, that solved the Module Federation. Second one is how we're going to do the cross-application communication. In theory, we should really keep that to a minimum because that's how you achieve the independent, right? So if more coupled and more hard to handle, right? But on the other hand, think about sometimes you do have a requirement that you need cross-application communication. Think about a product website. You have a list of product. You click into one link, and we will load the detail of that product. And you probably want to in the URL is sort of /ID =straight, right? Something like that.
So there's a couple ways of doing that as well. The first one is a custom event, which is probably the most straight way. You've got that event target building in JavaScript, but on the other hand, it's quite hard to maintain. Think about each pair of this MFE you want to talk about that. You need to define an API spec between that, and it can easily, again, get out of control, right? Second one is slightly better is mediator pattern via pubsub.js. The main container in the middle, and then every single MFE we want to communicate to each other, we actually push all the events back to container. Then you also subscribe to whatever the event you are interested to container as well. So sort of the container serving as the middleman, as the mediator to help all the MFE module to communicate, right? I put a question mark because we implement this way, but then later on we don't really find any sort of use case we have to use that because probably we did such a good job, right? So it's just sitting there and waiting one day if there's really complicated decoupled communication we want to attend, then we probably use that. Third one is what I just said, your parameter, which is most straight way, right? So like it just instead, so think about the main container, you initialize the history object. Instead of in the MFE, instead of you initialize the new one, instead you just pass on from the main container to the MFE one, so that it can enjoy this parameter passing as well as the navigation experience across everywhere, just like original one single application, right? Last option, we only have one use case, which is GW2 token. So like in the main container taking care of the authentication, and after that we have GW token. We want to pass on to different MFE modules, but we don't want to expose to anybody else. So let's say in the shared local store. And very similarly to history, you can just pass on that store to the MFE, and everybody can just enjoy reading slightly slower but safer. Cool. The last one, share modules. This is probably easier. So think about you have a professional UX team. You want the whole application share, no matter where located, you want to share exactly the same UI style, right? All those buttons, all those drop-down lists, tooltip, tree selector. So what we do is instead of local project folder or Git repository, we just just simply push to npm library, and everybody can enjoy that. Well, on the one thing you probably want to careful, like you don't have to do everything from the beginning, right? Think about it, you extract all this into the npm library, and all the MFE can use that. But then you don't have to immediately refactoring or coding the main container, right? So why not just save for a while? There's a lot more important things to do. So that's sort of the migration plan, right? So you pick up the most important thing to do first, and then you later on during the iteration you slowly to recover, slowly to back to the high standard you were at. Cool. That's most of the things I want to talk around the technology part. Let's look at the achievements. Basically, it was a monster, right? So 5,000 files under the main repo. And now we have only, to look at the front-end message, only 600 files, which is really cutie. No more hop. Functional tests, right? Obviously, think about it. Top right, you only have sort of 4 functional tests, bundle to get extract that into your new MFE pipeline, and then comparing to the rest of left in the main container, you can easily guess how much time difference in the pipeline, right? Bundle size, that's quite interesting. So think about that previously, the whole application is bundled together. It's quite big, right? So you have to download all of them at the beginning. But then later, since you have this MFE, if the customer only go to the one particular page, you only have to download the main container plus that page. If you don't navigate to the other page, you don't have to download it. Right? Think about how good is the user experience. And we also achieve that sort of average 1 to 2 tickets instead of comparing to that 20 tickets previously, right? Way less risky, which is amazing. Release process is not really tightly related to this MFE topic, but it's more like all the best practice we apply to our front end, unit test, functional test, persist snapshot, post-deployment test, or smoke test, right? Synthetic test more for monitoring. 100% test coverage was sort of tricky. Somebody really hated it, but we We try to stick to that. Fully automated with CDCI and fully managed by AWS CloudFormation. We can do rollback in this in 2 minutes. So all of this, you, as I said again, like you don't have to implement everything from the day one into MFE. You can just, what we did is actually some bare minimum from the unit test, right? We know we're doing good stuff, we are confident, so we do with the minimum stuff, sort of MVP, go ahead, and then later in the iteration, we gradually recover everything. Literally, we only re-enabled the persistent snapshot last week. So, cool. Go back to the previous question, right? So who actually gonna do the work, right? We have 3 teams. Everybody, right? Because it's important. Like everybody should on board. That's the future, right? So you can't just keep, committing into the main repo and think about, oh, maybe I'm the last one who left in the main container and I sort of by default become an MFE, right? It's very hard to happen. But the problem is who, when to start, right? Go back to the priority, right? For my team, it's urgent plus important because last year we barely survived in the last quarter. As I said, there's so many blockage from different teams. But the thing is, should we just do it now? How can we face our product team, right? We're friends, we're meeting every day. Can I say, sorry, I have to stop 2 months to do this. Would you mind? Probably it's not really fancy, good conversation going to happen. So what we're looking forward is a quiet period to do this piece of work, right? Typically, is you can choose in the middle of major product releases. Think about that during the early access program, and usually during that time, our product team will sort of collect feature, sort of customer feedback, CSS score, think about what's to be released next in phase 1 to 3. And during that time, we probably have sort of quiet period, can do this technical initiative. On the other hand, if you're lucky enough, we've got some offshore guys, probably don't celebrate Christmas, they can also help on this as well. And that's actually exactly what we did. So before that, we have a full Confluence page of detailed design, which every single detail, those technical details, what are we going to do? And we also have a big epic and all this front-end code, so a lot longer. I'll just make short of the screenshot. All this orange icon basically means code freeze, and then onto the sort of mid-channel already back, right? And 3 sprints of effort to extract that most popular page from the monolith to the micro front-end. At the beginning, is entire front-end teams work on that, and then later when Christmas happens, sort of half team gone, and after Christmas, sort of back, and then at the end, sort of 1 to 2 cars left with 1 to 2 engineers working on that. But then at the same time, unfortunately, product team also back, and they're already thinking about some new feature or urgent bug fixes. So that's going to be a negotiation, right? Okay, now we have this main container, we have this MFE as well. Do I have to do that right now so that I will have to duplicate the code in both main container and MFE? That's kind of a waste of effort, right? Is that okay? We just push back another sort of week or half sprint. Then we only commit. We're still doing the work, right? We've still got another half of the team. Let's commit all the changes into the MFE repo. And when we sort of have confidence, and at the end of sprint, we can just do a cutover, right? After the cutover, we immediately got everything, so not everything like that page we want to extract into the MFE and plus all the new features straight away. So that's how it works eventually and become a really happy ending with all this media organization. Cool, that's the whole story of my experience. And you can follow me on LinkedIn to give a guess which company I'm talking about, if you're really interested. Any question? Luckily, there's no more of those details which already answered by Gary. Any question? Yeah, please.
Kind of a no-code question, but like with having all these MFEs, how have you guys handled like documentation and making sure like if you have any team changes or someone new comes in and they have to get to grips with the MFE as quickly as possible, how do you manage documenting throughout the process of your migration?
Right, so the question is that if, whether we have sort of documentation that's mapping sort of which MFE mapping to which team, right? If there was any team the structure change, how can we
the
do?
technical, like how the MFEs interact with each other. Like, so for example, with the module federation, if you have like app 1 and app 2, do you document how to communicate with app 2 in app 1, or do you have all the documentation related to app 2 in app 2, and then you go from there? So do you guys document each of your MFEs, or just the overall end-to-end?
Yeah, I think it's more overall end-to-end, right? So the one thing, as I said, like the communication, we really want to keep as minimum. So that's why we didn't really use that pops up. It's there, but the idea is if we do need to define this sort of a spec between different modules, we definitely can easily have a look in the main container because everything is just there, or everything is just published and subscribed from there. But on the other hand, as I said, we don't really have that complexity. So most of the time, it's just quite a straight away from the URL, link the different URL can, just naturally go to the other modules. Yeah. So it's just sort of in the code, right? We on the other hand, we don't really want to document too much details in sort of conference page because things could change, right? Things change, people go and not necessarily update the documentation, but the code is always the code, right? It's working there and is for sure is true the source of the truth, right? So we would prefer like sort of comments or sort of refactoring this functional into smaller pieces, and you can basically self-explain itself what it does rather than formal documentation. Yeah. Any other question? So it's really answered all by Gary. I'm so lucky. Yeah, cool. If that's it, then yeah. Just to get, I think,
Just wanted to say thank you to the speakers, Gary, Mar, and Harry. There's lots of pizza left, so if you want to take some home, please do so. Otherwise, we should be packing up fairly soon, with hopefully getting people out before 9 p.m. Thank you. Have a good one.